Hello students, hope you all are doing great. So the topic we are going to study today is bond fission. Okay, this is the first topic of general organic chemistry. So bond fission is also called as cleavage. All right, we can also call bond fission as cleavage. What does the fission means? Fission means breakdown, and cleavage also means a breakdown. Breaking down means the cleavage, or we can say fission. All right, so we are having two types of bond fission. First one is heterolytic bond fission and the other one is homolytic bond fission. So in this video we are only going to study about heterolytic bond fission. There is another term used for heterolytic bond fission, that is heterolysis. Lysis is also known as breakdown. So these are the words that are similar, either that is lysis, or that is fission, or that is cleavage. They all are interrelated to each other, or we can say they are very similar to each other. We can just give them the one word, that is breakdown. Okay, so what happens in heterolytic bond fission? We are going to write the definition of heterolytic bond fission. Okay, let me write it in short form. So what happens in heterolytic bond fission? In heterolytic bond fission, unequal distribution of bonded pair of electrons take place. Bonded pair of electrons take place. All right, students. So now I am going to explain this term, how it happens, what is actually the heterolytic bond fission. So let's suppose we are having here so this is the tertiary butyl chloride. So here what happens, we can see there is a partial negative charge on chlorine and there is a partial positive charge on carbon dioxide. The reason for this is electronegativity. Chlorine is more electronegative. So here they have shared two bonded pair of electrons. Okay, they have shared two bonded pair of electrons. That means one is from carbon and another one is from chlorine. Alright students, so what happens in heterolytic bond fission? Unequal distribution of bonded pair of electrons take place. So there will be unequal distribution. How it is going to happen? Either chlorine is going to take the both electrons, or carbon is going to take the both electrons and chlorine will be left with nothing. And in another case, what is going to happen? Chlorine will take the both bonded pair of electrons and carbon will be left with nothing. There are two possibilities. I'm going to explain them. All right students, so it is like that. So it's like this. One possibility is this. I'm sorry students, this is my first video and there might be some errors like lightning problems, so this is the first try of mine. Okay, another possibility is like this. So what we have to do here, we have to unequally distribute them. So how we will distribute them unequally? Let me show you. For an example, we know these are two shared pair of electrons by both carbon and chlorine. They are shared by both the carbon and chlorine. So in first case, what is going to happen? This is the first case here. Here in this case, we know chlorine is having 7 electrons in its valence shell. But here what is going to happen? Firstly, carbon will take his own electron. There will be no charge because it's his own electron. So there is no charge on it. Now what is going to happen? Chlorine is having 7 electrons in its valence shell. So one electron is going to move from this place to this place to this place. So it is now it's going to acquire the charge that is negative charge. All right, because what is the reason for acquiring the negative charge? Because chlorine has given its electron to carbon, so carbon is acquiring the negative charge. So this is the reason for the carbon to take negative charge. First, it has only acquired his own electron, so there was no change, there was nothing changed, it was just his, it was a neutral, we can say. But when it has acquired the chlorine charge, chlorine electron, so what happens here? So it is going to take the negative charge, so it will acquire the charge that is known as negative. Okay, second case, what is going to happen in other case? What will happen? It will be like this. Here carbon is going to give his electron to chlorine. Chlorine first was having 7 electrons in its valence shell. Okay, it was having 7 electrons. We can write it like this: 1 2 3 4 5 6, and this is 7. But after taking the charge electron of chlorine, sorry, after taking the electron of carbon, it is going to take negative charge, as this was the case in above first case. It was happening with carbon, now it is happening with chlorine. So these are the two possibilities. I am not saying what is right here and what is wrong, I am just saying there are two possibilities that are going to happen. But here what we learned, but the thing is, this is not possible here, because we know chlorine is very electronegative as compared to carbon. So chlorine is having high electronegativity. But in case of carbon and chlorine, so chlorine is more electronegative, so chlorine is going to take the electron from carbon, not opposite, vice versa is not going to happen, because carbon is not that electronegative as compared to chlorine. All right students, I hope you are getting this. As this is my first video, maybe I might not be correct with the words or a little bit nervous, so I'm sorry for that. Okay students, this was about the two types of possibilities. But this possibility, the first case, is wrong, this is not going to happen. But this one is the correct, because chlorine is more electronegative than carbon dioxide. So I'm really sorry students, carbon. What other point where we will write in heterolytic bond fission is, in heterolytic bond fission, in HB, heterolytic bond fission, takes place in polar bonds. So have you seen here we are having polar bonds? If there will be no polarity in carbon, for an example, if there would have been same carbon on this side, there would have been no polarity. But there is a polarity here, because both are having different electronegative. So because of that, heterolytic bond fission happens in polar bonds. So that is the reason. Another one is, in heterolytic bond fission, ions are formed. All right. Another one is, reaction in which heterolytic bond fission takes place are also known as, we can also call these type of reactions as ionic reactions or polar reactions. And you know the reason for calling them ionic reactions and polar reaction. Why is it called ionic reaction? Because ions are formed, negative positive, so ions are formed. And why polar? Because there is a polarity in the bond, so because of that heterolytic bond fission is happening. So this is the reason The reason for this is we call them ionic reactions or heterolytic bond fission. So thank you so much. This was all about heterolytic bond fission. Hope you got the all the points that I have discussed in this video.